Bakit? Ha? Dede? Kafe atau napi? Dari Udapi negara itu kafe atau napi? Blank. Ingay naman nun. Kafe atau napi? No. Cellphone nyo. Ako yung video. Hello guys, welcome to another video, and for this video I will be explaining to you the topics about the TCP and IP and the OSI model, and also the R process and the topic about the encapsulation and decapsulation. So let's get started. So for the and TCP/IP and OSI model, so these two are the most used models in network communication, but the only protocol between the two is the TCP and IP, while the OSI model is just a reference model. So they both have their similarities, and they also have their differences, but they don't actually compete with one another. They're just supporting each of their purpose. So the OSI model is used, or is not practically used for the communication, while in the TCP and the IP is mainly used for creating the connectivity between creating creating or establishing a connection, and for the communication in the network. So the OSI model, it emphasizes some of the services, the interfaces, and some protocols, while the TCP and IP is not able to describe some of the concepts of those that the OSI model emphasizes. So this is the the layers that the OSI model and TCP or IP model has. So the OSI model, starting from the physical up to the application. So physical, data link, network, transport, session, presentation, application. While the TCP and IP model only has the network access, internet, transport, and application. Oh, they're almost the same when it comes to the layer. But then again, their range of their purpose is a lot different from one another. The TCP and IP model, it only enabled it only enables the connectionless communication in the network layer, but the transport layer possesses the connectionless and the connection oriented. So the TCP and IP model, it just means that the TCP is the transmission control protocol and the IP is the internet protocol. And for the OSI model, the OSI means the open systems open systems it's called the open systems interconnection model. So we will first tackle about the definition of the TCP and the IP. So as I've said, it is the transmission control protocol and the internet protocol. and it consists of four layers, which is the application, transport, internet, and network access. So internet protocols are used for the rules to define the communication over the network. It is a standard protocol model for networking. And some of the set of protocols given in the TCP and IP model is the TCP, UDP, ARP, DNS, HTTP, ICMP, and etc. It is used for interconnecting computers over the internet. So let's start off with explaining the layers one by one. For the network access network access layer, um, this layer acts as an interface between host and transmission links used for transmitting datagrams. It also specifies what operation must be performed by links like serial link and classic Ethernet to fulfill the requirements of the connectionless internet layer. And next is the internet layer. So the purpose of this layer is to transmit an independent packet into any network which travels to the destination. So the internet layer, it searches for the correct path for the packet in the network to go straight to the destination. So it uses the internet protocol, of course, and also uses the ARP, or the Advanced Resolution Protocol, as a standard packet format of the layer. For the transport layer, it enables a fault-free end-to-end delivery of the data between the source and destination hosts in the form of datagrams. The protocols defined by this layer are TCP, Transmission Control Protocol, and UDP, the User Datagram Protocol. And lastly, for the TCP and IP model, the application layer. This layer permits users to access the services of global or private internet. Various protocols described in this layer are virtual terminal, electronic mail, and file transfer. Some additional protocols like DNS, HTTP, and RTP. The working the working of this layer is a combination of application, presentation, and session layer of the OSI model. So the application layer in the TCP and IP model, just the combination of the application, presentation, and the session in the OSI model. So next off, we will start with the I will I will explain the OSI model. So in open system interconnection, which was introduced by the ISO, or the International Standard Organization. It is a model, not a protocol, and the main concept is layering. So the main intent of the OSI reference model is to conduct the designing and development of the digital communication hardware, devices, and software in a way that they can efficiently interoperate. So let's go with the 7 layers of the OSI model. So starting off with the physical layer here down at the bottom. Transmit the individual bits over the transmission channel. The physical layer deals with the description of the characteristics interface of the interface between the devices and transmission media. Representation of bits, synchronization of the bits, data rate, physical topology, line configuration, transmission mode. Next up is the data link layer. It is responsible for transforming the raw transmission service into a reliable link. It makes the physical layer free from error by masking them so that the network layer does not notice them. In this layer, the input data is split into frames. The tasks carried out in the data link layer are framing, access control, physical addressing, error, and flow control. So it creates the data link layer. It, it transforms error transmission. It transformed the physical layer to a reliable link, and it helps to avoid some of the errors that the physical layer can where that can occur in the physical layer, the errors that. So the data link layer, it splits the data into frames. So for the network layer, logical addressing and routing are the major operations performed in the network layer. Translates the network logical into physical MAC address so that the two systems residing in the different network will also communicate efficiently. A packet also requires a path to be followed to reach at the destination, avoiding congestion and failed components. So it also facilitates the automatic updation of the routes. So in the network layer, this the logical addressing and the routing enters at this stage where we starts we start to learn the setting up of the addresses on devices, and also the the routing or the searching for the path of the connection. So next is the transport layer. It accepts the data from its preceding layer in the form of independent packets and transmits it to the succeeding layer in proper order. The other function carried out by this layer are service point addressing, connection control, segmentation and reassembly, flow control, and error control. For transport layer, it is responsible for proper for keeping the data to be sent in proper order up to the next layers. So it is also responsible for the segmentation assembly, flow control, and error control. For the session layer, this layer establishes the session between different machines in order to synchronize and maintain the interaction between them. The services provided by the session layer are dialog control, token management, and synchronization. For the session layer, um, it is the layer that enables some devices to create a session or to interact with one another, and to keep the communication synchronized. For the presentation layer focuses on the syntax and semantics of the transmitting information. It performs tasks such as translation, encryption, and comparison with the actual information existing in the form of character strings, numbers, symbols, and content into bit streams converted into another form and compressed. So the presentation layer it is responsible for the transmission of the information that flows through the whole network. Also, it performs some tasks as given the translation, the encryption, and compression. So it converts the some information into bit streams, and it is compressed. For the application layer, with this layer, the users can access the network using interfaces and services like electronic mail, shared database management, file access, transfer the other services. So in the application layer, this um our end devices is involved because as the layer suggests, it is the application. So it is like the application that we are using for the for the benefit of communicating. And also we this layer is responsible for the file access or the file transfer and many more addresses. And that's it for the OSI model. So let's go straight to the wait a minute. So let's go straight to the R process. So the R process or the address resolution protocol is a protocol used for resolving IP addresses into MAC addresses. And for for this protocol, this just shows the how how a source host can how a source host can search for the missing MAC address of the destination host by creating a ARP request and searching and begin searching for the IP addresses that it needs. And of course, after the destination accepts the ARP request or verifies it, then the destination will reply an ARP and will respond with an ARP reply for the host for the source host to be able to send the data that it wants to send to the destination. So it starts with the initiator sending an ARP request as a broadcast frame. So as we can see here, the host A wants to send something to host B. And first, as we have the ARP request, it will automatically broadcast a it is a broadcast because it wants to verify if which of these three desktop computers are is the one that it was searching for. So it must gain the MAC address also. But given the IP address of the IP address that wants to find, then the MAC address must be searched also. The request must be broadcast because at this point the initiator does not know the target MAC address and is therefore unable to send a unique frame to the target. So as the source, after the source has found out the MAC address of the destination, then can it can send the data in a unique frame. So it can just send it straight to the destination. Uh, since it was a broadcast, all nodes on the network will receive an ARP request. All nodes will take a look at the content of the ARP request to determine whether they are intended target. The nodes which are not intended target will silently discard the packet. So if, for example, here the host A wants to send it to host B, and then if the if an ARP request is received by the host C and host D, or if didn't match the IPv4 address that they have, and then they will reject the frame and will move towards the other devices. So that's just it for the address resolution protocol, because it's just a basic protocol to master, and it's just all about the requesting and the replying of the host and of the source host and the destination. Next is the encapsulation and decapsulation. So the encapsulation, this encapsulation, decapsulation are like types. So encapsulation, when data moves from upper layer to lower level of TCP or IP protocol stack. So each layer includes a bundle of relevant information called the header along the actual data. The data package containing the header and the data from the upper layer then becomes the data that is repackaged at the next lower level with the lower layer's header. Header is the supplemental data placed at the beginning of a block of data when it is transmitted. This supplemental data is used at the receiving side to extract the data from the encapsulated data packet. This packing of data is each layer is known as data encapsulation. So encapsulation is just the inserting some, it's like a delivery package where the some of the items must be some of the items that someone has ordered online, for example, it must all be inside the box after they receive it, or before they receive it. And for the decapsulation, it is the reverse process of the encapsulation. It occurs when the data is received from the destination. So from the encapsulation, it goes down the layers in the OSI model, and after going to the lower layer, and then it moves to the other layer, other part of the OSI, and then in the decapsulation, it's just the reverse thing. It will go up to the layer. As the data moves up from the lower layer to the upper layer of the TCP and IP protocol stack, each layer unpacks the corresponding header and uses the information contained in the header to deliver the packet to the exact network application waiting for the data. Okay, so the reverse process, so the encapsulation, it inserts some of the data in the TCP and IP model, uh, and it inserts some data from the application layer to the network access layer. While the decapsulation, it returns the data back to its original state. Just like some, it unpacks the corresponding header to, in delivering the packet to the exact network application waiting for the data. So here in this image, so the encapsulation is adding header and trailer to the data, and of course the encapsulation, after having the having to move in the TCP IP model, it will remove the it will be removing the header and the trailer. We're rejecting them to get the data. So the header and trailer supports in sending the data towards the destination, and the encapsulation is the encapsulation the encapsulation decapsulation, it gives the safe data to the destination. And that's it for this. That's it for this video, and I hope you learned from this video, and thank you for watching, and